Solving rational expressions, Part 1. Solving rational expressions. The first thing that you want to make sure of is that you do have an equation. Remember, the equal symbol is what tells you you have an equation. And so we're going to solve these. For our method, the first thing we have to do is to state any excluded values. And we're going to throw those out. When we get to the end of the problem after we've solved, we will look back, and if our answer is one of those excluded values, we have to throw that answer away. Step 2, we will find the LCD. So find the least common denominator. Step 3, multiply every term on both sides by the LCD. You do not get it underneath like an addition and subtraction problem. You multiply by it on the top. Simplify. All denominators should cancel. If not, you did something wrong. Solve, and then look back and make sure that your solution was not an excluded value. So let's look at an example. It is an equation, so we have the right kind of problem. Let's check for excluded values. The only place we have a difficulty is just the x in the denominator. The constants are fine. And if we put 0 itself in place of the x, that would make it undefined. So 0 is the only value we're going to throw away. Right. Next, we will find our LCD. So we have to cover all the denominators that are here. 4 is made out of 2's, 2 times 2, and we have a 3 and an x. They're all different, so we're actually going to need everything. So our LCD, when we put it together, is going to be 12x. Now we're going to multiply every term on both sides by the 12x. Right, now we have 12x times each one. We're going to clean up. So we're down to our simplify step. This is really 12x over 1. On this first piece, the x is going to cancel on the diagonal. So we have 12 times 7, which is 84. On the next one, we'll simplify, and our 3 goes into 12 4 times. So we have a minus 4x times 1, which is a minus 4x. And on our third piece, our 4 will cancel on the diagonal. 4 into 12 will go 3 times. So 3 times x times 1 is just 3x. And now we have a linear equation to solve. So we'll isolate the variable. We have x on both sides, so get rid of one of those. I'm going to add a 4x to both sides. So this is what I had, and I'm adding 4x. Bring your equal straight down and add your 4x on this side. It is fine to do the step in your head. Clean up. So 84 equals 7x, and divide by 7. So x equals 12. All right, we have one more step. We have to look back at the excluded value and make sure that 12 was not an excluded value. Our only excluded value was 0. So we're fine with 12 for an answer. That is our solution. Here's another example. It is an equation, and we have some fractions. First, we will find our excluded value. The only denominator where we have a variable is just x. So 0 itself is the only thing that's going to make it undefined. So 0 is our excluded value. Our common denominator on this problem is just x. And we're going to multiply through on both sides by x. So we're going to do x times everything. So x times x plus x times 3. And also x on the other side. X times 10 over x. And then we'll simplify. For our first term, x times x gives us x squared. There was nothing to cancel. Second term, x times 3 is 3x. And on the right-hand side, the x will cancel. This time we ended up with a quadratic equation. So we need to get a 0 on one side. So we'll subtract the 10. And then remember we have to factor to solve. So we want different signs. And how about 5 and 2 to get 3? So plus 5 minus 2. And then set each piece equal to 0 to solve. So x plus 5 equals 0. 5 is added, so take it away. And x minus 2 equals 0. X is subtracted, so add. So we have found two solutions. Just look back and make sure that neither of these were excluded at the beginning. Only 0 was excluded, so we're fine. Our solutions are -5 and 2.